I'm Rajyalakshmi from CIET. So today I'm going to share the topic algorithms. So algorithm is generally refers to a set of instructions that can be executed by a computer to produce the desired result. So it is a step-by-step procedure to solve a particular problem, and it is any well-defined computation procedure that takes some set of values as inputs and it produces some set of values as output. So, an algorithm is a step by step procedure which defines a set of instructions to be executed in a certain order to get the desired output. And the algorithms are generally created independent of underlying languages. That is, an algorithm can be implemented in more than one programming languages. So, generally, the notations of an algorithm are a non ambiguity requirement for each step of an algorithm cannot be compromised. And the second one is that the range of inputs for which an algorithm works has to be specified carefully. The same algorithm can be represented in several different ways, and several algorithms for solving the same problem may exist. An algorithm for same problem can be based on very different ideas and can also solve the problem with a dramatically different speeds. So these are the notations of an algorithm. And what is an algorithm? So an algorithm is a step-by-step procedure to solve a particular problem, and it takes these some values as inputs, and it produces the values as outputs. Some values as output. Algorithm properties. So here we have five types of properties, and first one is definiteness. So definiteness, an algorithm must always terminate after a finite number of steps. Finite number of steps. So each of which may require one or more operations. If we trace out the instructions of an algorithm, then for all cases the algorithm terminates after a finite number of steps. So that is a finiteness. An algorithm must always terminate after finite number of steps. So next property is definiteness. So each of an algorithm must be preciously defined, meaning that the action to be carried out must be rigorously and ambiguously specified for each case. So operations such as compute, for example, 5 by 0 or add 6 or 7 to x. These operations are permitted because it is not clear what the result is. So, which of the two possibilities should be done? So this is a definiteness. Each step must be precisely defined, and the action to be carried out must be rigorously and ambiguously specified for each case. And next property is input. An algorithm has a zero or more inputs, takes takes from a specified set of objects, and it generates the same set of objects as output. So next property is output. An algorithm has one or more outputs which have specified relations to be inputs. And the last property is effectiveness. An algorithm is also generally expected to be effective. So the in the sense that is operations must all be successfully basic, that they can be principle be exactly finite length of time, and someone using a pencil and paper performing algorithm arithmetic operations in so these are the effectiveness. They are all operations to be performed must be sufficiently. This is the process for designing and analysis of algorithm. These are the steps for design and analyze an algorithm. So the first step is understand the problem. So first we have to understand the problem, which technique is suitable for complete the task. And second one is decide the problem solving technique. So it is the time to formulate a problem solving technique. So the solving techniques like greedy method, divide and conquer method. So these are the methods, which technique we have to choose one technique. And third step is design an algorithm. An algorithm design technique is a general approach to solving problem algorithmically. So in this design technique, there are a number of standards methods for designing an algorithm. The most important among them are divide and conquer, greedy method, dynamic programming method, backtracking method, and branch and bound method. These are the five techniques for designing an algorithm. And fourth step is validate an algorithm. An algorithm validation checks the algorithm result for all legal set of inputs after designing the algorithm. And next step is analyze the algorithm. So in situation may occur where many algorithms are available for solving particular problem. It should be noted that data structure can be represented in many ways, and there exist a number of algorithms to be implemented and an operation. Such cases require a comparison of two algorithms. So to implement one operations to be said data structures, and later better one is chosen. So the analysis of the algorithm focuses on time complexity and space complexity. So as compared to time analysis, and analysis of space requirements for an algorithm is generally easier, but wherever necessary both techniques are used. And the time complexity and space complexity, both the techniques are used. The amount of memory needed by a program to run a completion of a program is referred to as space complexity, and the amount of time required to complete or required to run a program is called as a time complexity. The sort of time and space complexities are done in a analysis phase. And next step is coding an algorithm. So coding an algorithm is an important task, implementation process. So in here we have two phases. So first one is two testing phases. So first one is debugging, and second one is profiling. So the two test cases are run in a coding part. So debugging is the process of executing program on some sample data sets. So determine whether a faulty result occur, and if so, to correct them. So any errors will arise here. So we have to correct the all errors here. And the second one is profiling. So profiling is the process of execution process preferred to data sets. So here we have to we have to calculate both time and space complexities. So it's called as a profiling. Calculation of time and space complexities is known as a profiling. And last phase is algorithm testing. The efficiency of an algorithm is writing efficient program is what every programmer hopes to be able to do. But what kind of programs are efficient? The question leads to concept generalization of programs. So the algorithms are programs in general form. The algorithm should meet three things. So first one is that should be independent of programming language in which idea is realized. And second point is every programmer having enough knowledge and experience should be understand it, and it should be applicable for input of all sizes. In the pseudocode for experienced algorithms, hypothetical languages used to define algorithms is pseudo languages. So the general procedure for writing a pseudocode is presented. All comments must be begin with a slash, and blocks are indicated with matching braces, like a curly braces. And the third point is an identifier begins with a letter. and the assignment values of the variable is done by using assignment operator. There are two boolean values, true or false. So these are the pseudocode for an algorithm. And the efficiency of an algorithm denotes the rate at which an algorithm solves a problem of a size n. It is measured by the amount of resources it uses and the time and space complexities also. The time refers to the number of steps the algorithm executes, and the space refers to the number of units memory storage requires. An algorithm complexity is measured by calculating the time taken and the space required for performing an algorithm. The input size denoted by n is one of the parameter characterizes the instance of the problem. So this is the introduction for an algorithm. Thank you.